Hello, my name is Ben Benson, and my presentation topic is relational databases, but more specifically, it is how relational databases can break down a silo problem in a university and how that can in turn contribute to greater student success outcomes for staff, students, and ultimately universities. So, as a higher education professional, this is something I think about a lot. I work with a lot of data. I work with a lot of different areas on campus and systems that use different data that I then have to track down. So this is this is a topic that's very near and dear to my heart. So the problem, as I mentioned, a lot of these disconnected data systems fail students. Any student name I use is just completely made up in this, but just as an example, I want to present you with one student profile. Uh, Sarah has missed 3 advising appointments. Her class attendance has dropped to 62%. She has no campus event participation. That means events or campus organizations. And her GPA declines from 3.2 to 2.1. Now, the issue with this is that we all know that GPA declining is bad, but I think a lot of research would back up that each of the previous things contribute to that. And the issue is that there is a disconnected response that an academic advising will see the missed appointments. The faculty may notice that class attendance has dropped, and student engagement may see declining participation in the aggregate, not necessarily at individual students. And unfortunately, no one is really there in the middle to make sure that all of these things are tracked properly. So, what this normally leads to is that intervention occurs way too late. They've already demonstrated these warning signs, and in some cases, they may have already unenrolled from a university. So, the current state is that at Georgia College, for instance, academic advising and student success utilize a database called Slate, and that is new that both of them use the same thing. Student engagement uses Campus ES or not Campus ESP. They use GC Connect, which is a completely different thing. Academic advising tracks GPA, tracks degree progression, and knows their appointment records. In the old way, they may have been kept in isolated spreadsheets and may be seen in weekly reports. Student engagement, they may see aggregated event attendance, not necessarily event attendance for one person, although that may be available. Um, they may see campus involvement across, again, possibly aggregated. They'll see activity participation, again, possibly aggregated, not necessarily individualized. But these things, the important thing here is that these are kept in separate databases and they don't have academic context. Student success will track these other things like retention, performance metrics, risk assessment, but it may take them some time to get that data. So if we want to know how many times a student has gone to student support services like the Learning Center, that takes time because we have to go to uh, whoever is tracking that data. We have to make sure we are asking for exactly the thing that they need, and then we have to get it and then clean it, import it, and make sure it matches up with everything else. Um, and that just takes a lot of time. So the result is that students will fall through the cracks due to this fragmented information and loss of time. So a proposed solution would be a student or a unified relational database architecture. So students would these are essentially the fields that would be used. So student ID is 9 characters long. It's a primary key. It's how we match the first name, last name, and everything. So I'll leave this up for just a second while I talk, but this is essentially how we would set up the tables or each table in the database. This is not necessarily all of the tables that would be used in the database, but for the purpose of this, just tracking for early alerts, these are probably the most important tables that I would use. So their academic performance, which is linked by a foreign key, their appointments, which again does link to a student ID foreign key, the event attendance, class attendance, and courses. Um, I would change probably on status check under appointments instead of scheduled, completed, and no-show. It would be scheduled, completed, rescheduled, and no-show, because we do have some students that like to continuously reschedule and never come in. There, under event attendance, there's a check-in method to check whether uh, the students have used QR codes, card swipes for their Bobcat card, or a manual like sign-in. Um, and the reason I included this is because it would be a very good idea to be able to see what students are actually using in order to check in, and then to move our events that aren't using that to using that. So for instance, Slate, the database that we use in student success, does this nifty thing where it attaches a QR code that is specific to the record. So anytime a student goes to something, that QR code can be sent to them after registration. It can be scanned, and that is what marks off whether they have completed, attended, or are no-show. Um, it also does this thing with geo tracking, but it's not as specific as I would like in order to use it in a reliable way. But um, because of the foreign keys, this does enable cross-dimensional analysis, so we can really drill down into different things if necessary. But because this is the early alert is the focus and how the relational database would help that, I wanted to focus on what a query might look like. So in this case, we're pulling the student ID, the first name and last name. We're pulling the distinct number of missed appointments as missed appointments. We're getting the average attendance rate of the student for each class. We're getting the count of events that they have been to by counting the different event IDs. We're getting current GPA. We are also getting the number of appointments that they've had, the class attendance that they've had, the events that they've had from these different tables. But more specifically, we're only looking at the appointments that have a date within the past 30 days. We're grouping everything by student ID, so we all get one row for everything, so it's nice and clean. Um, we want to look at the records that have a missed appointment count of two or more. We want to get the average attendance that is less than 75%. We want to get the students that have zero events attended. And then finally, we want to order it by the missed appointments. So that's our risk criteria. Ideally, we would have a formula that would kind of take all of this, put it like weight different criteria, and then spit out a risk assessment. But it would, hopefully the output would look like this. Obviously the name would be split to first name, last name. I just did this to make sure it fit. But we have student ID that is specifically 9 characters long. We have the name, we have the missed appointment that checks out, the attendance checks out, the number of events checks out, and the GPA checks out. And then all of these factors indicate that this student is at a high risk of unenrollment and not being retained, which is what the university um, want or doesn't want. And the students supposedly would like to be successful. So this is a way we identify the ones that are not. The immediate things that we could do with this is then send alerts to success coaches and say, here are the names that you need to contact. It could trigger personalized outreach campaigns by setting these students into a population. And that population could also fall into an encouragement to schedule these priority intervention meetings. And it could help different departments coordinate these support strategies. So before we would have data scattered across departments, there might be manual reports that someone just had to think about pulling. The student profiles would be incomplete. It would be very reactive, not proactive, and it's difficult to look at patterns when you don't really have as much information. And then it just takes a lot of time to go to different places to get those. So after this, with a relational database model, such as the one that I'm proposing, we would have a unified data warehouse where all of these things can be found. We would have close to real-time alerts. We would have a holistic student profile, which is important, and we'll touch on that in a minute. We would have proactive intervention, or we would be able to have proactive intervention. There would be much there would be a much greater ability to detect patterns, and then we would have quicker query results with proper training of how to pull queries and how to get the data that you're looking for. So uh, the overall expected impact would be faster alert response times for staff, students, and for the institution, and it would have the following benefits. It would increase at-risk student retention or just overall student retention, and it would have a reduction in data search time so people could spend more time actionalizing data rather than um, searching for it. So for staff, we could have automated reporting, and we could have coordinated interventions, better risk alerts for students. They'd get the support they need. They would get it when they need it. They would get personalized outreach, and hopefully have better outcomes. And then finally, for the institution, they'd have higher retention rates. Their decision making would be much more likely to be data driven. Hopefully, resources could be optimized, and there would be a measurable return on investment. Because even from like an event standpoint, we could see which events held by which departments are having the most success or most attendance. So this is essentially what it would look like. We'd have the hub with each of these different tables. Um, so the not correct, but essentially departments and stakeholders within those departments would have access to the comprehensive data. Um, Ideally, we would train them to be more discerning with it, to be able to look for things that might not seem right before reporting and creating actions on it. And then finally, a lot of universities are moving to a holistic version of student success, which is important. It is good. But if that is the case, there is an incongruence with how we track their success. And that's the point of this relational database model, and this is why it would help. Um, Despite wanting to look at a holistic student support, we often look at the traditional markers of success, GPA, maybe class attendance. And while those things are necessary to look at, they are not everything that should be looked at. Because current data systems tend to remain fragmented and siloed, different areas on campus, the writing center, learning center might use different things. The relational database would enable a more comprehensive analysis to get those early intervention things out. Um, these data-driven approaches would help transform our success operations, show us things that might not be working that we've always thought did, or may have unintended consequences. So by unifying all of this siloed data into a relational database architecture like the one I've proposed, institutions can transform this idea of holistic support into an actionable reality by focusing on holistic assessment and analysis. Um, the database can do this through identifying at-risk students earlier, intervening more effectively, and ultimately improving retention rates and student outcomes. Thank you.